Okay, so what we're going to do first of all for this question is just make sure we understand what a geometric series is. So we could start from something like, let's imagine this is an example of a geometric series. 1, 2, 4, 8, 16, 32. What am I doing? I'm doubling it each time. So with a linear series, I'm going up in an equal amount. In a quadratic series, it's the second difference. We work out this second difference. But this is a geometric series. It's not the differences on, they're always going to be different. And it's not how much it increases by, but it's by what proportion does it increase. And so we're not adding, we're multiplying. So we'll just kind of, I'm not going to properly teach this topic right now because we're going to focus on this question. But essentially, so I'll write it up here. Xn, which refers to the nth term, this is another way of writing the nth term, is equal to a multiplied by r to the power of n minus 1. Let's put that in brackets. So what's A? A is the first term. R we call the common ratio, and that's the amount it multiplies by. So in my example, the common ratio is 2 because I'm timesing it by 2 each time. And then n minus 1, the n is referring to whichever term it is. So if we look at how this expression works, we'll see that it works because, I just want to get rid of that bracket because it's a bit difficult to see what's happening. Okay, so if we remember that anything to the power of 0 is 1, then when n is 1, we're having r to the power of 1 minus 1, which is r to the power of 0, which is 1. So on the first term, this all becomes 1, and the first term becomes a, which is, as I said, is what the first term is. So that's why a is the first term. And then what happens is we multiply it by the common ratio. So we multiply a by 2 for when n is 2, because when n is 2, we end up with r to the power of 2 minus 1, which is r to the power of 1, which is just r. So we're multiplying it by the common ratio. So we could go any further and talk about how the rest of them work as well, but essentially this is the formula. So for example, if I wanted to work out 1, 2, 3, 4, the fourth term, if I wanted to work out x4, it's going to be 1, which is a, times r to the power of 4, times 2, because that's what r is in this case, to the power of n minus 1, so it's 4 minus 1, which is 3. So 1 times 8, which is 8. So that's the formula. Now, let's look at this specific example. They've made it a lot more complicated because they've given the expressions as these expressions as some of the terms in the series. So given that this, this, and this are the first three terms of S, find the value of X. Right, well, so the first term, which I can call X1, is equal to root, it's a bit confusing that I've got to, okay, this is going to be a bit confusing. I'm going to, instead of calling the first and second term and calling it X, I'm going to call it, what should I call it? T for term, okay? So term 1, and so up here, let's just change this. On the textbooks, it'll say X, but I'm going to change this to capital T for term. So T1 is equal to the square root of some mystery value minus 1. That's the first term. The second term is just 1. And the third term is equal to the square root of the same mystery value from the first term plus 1. Now, and then apparently got to find the value of what x is. So if we know that that this is the formula, then we can say that this is equal to the first term multiplied by r, which we don't know yet, multiplied by n to the minus 1 in this case would be 0. Oh, of course, here we go, you see. The first term is that. We knew that already because it said it's the first term. And the second term is equal to a times r, which we don't know, like I said. And the third term is equal to a times r squared. Well, because we know that a is this one here, then I can, for the first situation, for the second term, I can put all this in place of a. So let's put that in brackets. In fact, let me just pause the video and use a little bit of colour here to help us to see what's going on. Okay, so if we say that, where it's written a, I'm going to instead use what we've identified is our value for a. And let's use black as the neutral colour. And that's been multiplied by r. So I'll put that like that. So that's term 2. And term 3 is a times r squared. So that's going to be equal to, well, we already know what a is. For this one here. Multiplied by r squared. Okay, right. Okay, so what we'll do then is we'll just the first equation has kind of already been used within the second equation, so we kind of, first equation sort of served its purpose. What we'll do is we'll just take this second equation and that's the summary of our second equation, and then we'll take our third equation and we'll just take these bits here. Now, what's the next thing to do? All right, so we just, I think it just makes sense just to take this one here and rearrange it. So that means that so this is, I should number these equations just so as we can tell there are different equations. This is equation 1, this is equation 2. So we're making r the subject, and what we've done is we're going to divide both sides by this bit here. So that's going to be equal to 1 over that bit in orange. Whoops. Yeah. Okay, so that's that. And now we're going to put this into this bit here. Now, actually, to be honest with you, we can actually just cancel out this factor here. This is interesting. Okay, I can't remember if I include this in the video or not, but I'd forgotten to notice that this is -1, this is +1, so you definitely can't cancel these out, and that was what was confusing me. So basically what we've got is we have a solution, we have an answer for what r is by just rearranging this formula here, which is correct, and we're just then going to put this into that one there. So instead of writing r squared, I'm going to write all of this squared. So let's just write another equal sign there and write this That's going to be at the top, and it's going to be divided by all of that squared. Now, because of that, we've got essentially something multiplied by itself squared. So the top, it basically ends up becoming that again, which is actually just r. So basically, x plus 1 is equal to r in the end. So actually, that makes that I could have worked that straight away, because we had 1 and then we went to term 3, and so clearly it's been multiplied by x by all of this. So I could have done that a lot more quickly if I thought about it. Okay, all right. So what have we got to? So we've got, and it's going to take. Oh, let's take all of this and shrink it a little bit, and we end up with this term here is equal to this term here. Now, when we multiply out both sides, we end up, and I had a feeling this is going to happen, we're going to end up with a really classic difference of two squares formula. Just a little reminder about a difference of two squares formula then. Let's just do that. If I had a plus b multiplied by a minus b, if you factorize this out, you will notice that you get a squared minus b squared. Okay, so if you are familiar with this, then you can quickly see it just speeds up the processes if you know that's the case. So the reason why that's what we're going to get here is because when I multiply both sides by this bottom bit, I end up with that. Let's put it in brackets. I think I need to make my pen a bit thicker. Oh, okay, it's as thin as. Oh, yeah, okay. I want my black pen. That's why. Okay, and that's going to be multiplied out by this, which I'll make a bit bigger, and that is going to be equal to 1. Okay, right, we're getting close. Now that we can see that. Okay, tiny bit. I think I know what's going to happen. Yeah. Okay. Yeah. Good. So we're going up with x minus 1 is equal to 1. So adding 1 to both sides, we have x is equal to 2, which is therefore the answer. Okay, which is the right answer. So yeah, we got there in the end. I don't think that was the most efficient way, but yeah.